How can we solve transportation problems related to crumbling infrastructure, surging congestion, poor air quality, increasing GHG emissions, and declining revenues? One proven approach is to implement a range of mobility pricing strategies, including road tolls, parking fees, gas taxes, and transit fares. Since this is easier said than done, especially in a COVID altered world, transportfutures.ca invites you to learn from and with international experts during our online mobility pricing conversations now underway. The fourth 1 hour session, taking place on December 7th at 1 p.m. Eastern Standard Time, features Randall Thomas, administrator of Road Usage Charge America. He and Transport Futures founder Martin Collier will discuss exciting progress being made with distance-based road pricing in the United States. With the Infrastructure Investment and Jobs Act signed into law in November 2021, the U.S. federal government is now working with 20 states to pilot a national road usage charging system, which could help manage increasing infrastructure costs and declining gas tax revenues. They look forward to responding to your questions and comments. Join this cutting-edge conversation, co-sponsored by Daily Commercial News, by registering today at transportfutures.ca/MPC. Hello and welcome to the Construction Record Podcast. I'm digital media editor Warren Frey. On this episode, I speak with two experts about the interaction between severe weather and built forms. First, I speak with Mark Robinson. He's a meteorologist for the Weather Network, and he co-hosts the shows Storm Hunters and Unearthed. He's also an accomplished storm chaser, and since 2000, he's seen extreme weather events across the planet, as well as the aftereffects not just on people, but on the structures that shelter them and provide essential services to communities. In the upcoming interview, he talks about some of the worst damage he's seen, as well as how the construction industry can and is building resiliency into structures as we face ever-increasing effects of climate change. Here's the interview. So I guess we'll start with, you're a meteorologist for the Weather Network, and you're also something of a storm chaser. In fact, you have a show about that. So you've seen your fair share of storms all over the world.
Yeah, no, I've been through 26 hurricanes now. I think around 100 tornadoes. I've been in blizzards. I've climbed into active volcanoes. I've been to Mount Everest. I've been to Antarctica. I've just been sort of all over the place and gotten to experience, weather and major disasters sort of all over the world.
hmm And so part of that is that's where construction comes in, is
Yeah.
buildings and resilience towards storms. What are some of the most interesting, innovative uses of building materials or design that are meant to sort of not repel, but sort of mitigate against
Yeah.
storms and the
Well,
like?
one of the things that I was just sort of trying to think of, like, the different ones I've seen, but of course the most interesting one that I think I've seen was actually in Nepal.
hmm
If you remember, they had an earthquake in 2015, and a lot of the construction there was done basically just bricks and stones stacked on top of each other without a lot of structural support. When we arrived in 2020, that was 5 years later. There was still massive destruction all
hmm
over Nepal. So we would go and check out different spots and different places, and in some places and in some cases, it looked like it had just happened. The one that strikes me as sort of the one that I remember really well was a small monastery on top of one of the ridges in the Himalayas, and it had been constructed with a gigantic concrete slab across the top. So it was basically just stacked up rocks and then this giant concrete slab. And when the earthquake hit, the slab sort of collapsed down on top of a lot of what was sort of below there.
hmm
And you could see where it cracked, where things let go. What was interesting, though, was as we were driving around Nepal, you could see where they were now sort of really upping the construction, the engineering. So they were now using, you're going to know the word better than I do, but rebar is what it
Right.
looked like,
Yes.
big
hmm
steel poles, flexible steel poles within the construction itself. So it looked like older construction, but actually in the center of it, there was this rebar that would sort of stick out of the top. And what they would do is build it up high enough and then cut that off and do the construction that way.
hmm
And basically, it was all designed for another earthquake to happen, and for the whole building to be able to sway a bit, so that it wouldn't instantly, be brittle and instantly collapse.
Mhm, mhm.
And that was sort of done in all the new construction, the construction of the buildings that had collapsed already. But there was still, hundreds, if not tens of thousands of buildings that hadn't collapsed, that may, collapse if you've got another earthquake. But those buildings that they've rebuilt will handle that swaying.
That reminds me of I was in Tokyo slightly before the big earthquake hit Japan in 2011. So I think myself and my ex at the time left. We felt tremors in Tokyo beforehand that we thought nothing of. But I remember the tsunami and the Fukushima and all that was not great. But Tokyo itself didn't really get all that much damage. Like it scared the hell of a lot of people for good reason because it was a big earthquake. But the way
Yeah.
that place was built was incredible. It's all concrete basically. It's incredibly solid.
Yeah, and there's a little bit of it's allowed to sway, take up that little bit of that energy,
Hmm, hmm.
that sort of, and that's what one of the big things they were doing with those buildings in Nepal was to, like they basically said, we know it's going to happen again, and it could easily happen as bad as they saw it before. And the idea was to sort of try and update these buildings as best they could. And keep in mind that Nepal's an extremely poor country.
Hmm.
So, a lot of the construction was taking place over many, many years, as opposed to, if we were doing something in Canada, we would expect things to be done, within a year.
Right. Yeah.
Unless you're the Eglinton, subway line. But
Well, one of the, I guess we should go closer to home. You are based out of, I believe, Ottawa, and that's where there was a tornado, a few, a series of them, I think, last year. So, what did you see in terms of buildings, in terms of damage, and also in terms of what people were doing or already had done to sort of
well,
to
I'm
prepare?
actually based out of Guelph.
Oh, sorry.
Yeah, no, that's all right. But like, so I've seen tornadoes all over southern Ontario.
Hmm.
And one of the interesting things of what sort of the kind of storms that we see in Ontario, and this does get a little bit into the topic of climate change, is we mostly build for snow load. We don't really think that much about wind load,
Hmm.
and wind lifting. So we don't put hurricane straps on buildings. We don't really sort of anticipate that that's going to be a big problem. But as we get into a little bit more of the effects of climate change, Southern Ontario and in and around the Great Lakes is likely to be the least affected by climate change within North America,
Hmm.
and that's thanks to the Great Lakes. But at the same time, we are seeing an increase in the number, or at least in the potential for thunderstorms and tornadoes. Tornado Alley itself seems to be, and there's some evidence for this, that it's beginning to move northeast. So the tornadoes that we saw in, say, Kansas and Texas and those areas may be moving a bit towards southern Ontario. So we may actually see an increase in those type of storms,
Hmm.
as opposed to a huge increase in the amount of snow that we're seeing. Now, having said that, we also, as the lakes say don't freeze over as much, and we saw this last year. We're seeing, like, in those snow belt areas, like Barrie and Bracebridge and Aurelia. Those areas may be seeing a lot more snow because of the lakes staying open, and those lake effect snows are able to sort of continue right through the entire winter. So we're definitely seeing, and I've been seeing some of these issues. If you jump over to Barrie, there was a tornado there a few years ago, and one of it hit a very, very new neighborhood. I mean, it had literally been put in within the last 5 years before the tornado hit. And what was interesting about that was that it uncovered a lot of really shoddy construction.
Hmm.
So when there was supposed to be, a certain number of bolts put into the ground per foot or per meter, it was half of that. There was bolts that were put into the garage. Concrete in the garage was supposed to be right in the middle of that concrete. Instead, they were sort of off to the edge. And what that allowed for was the roofs to sort of pull off. And it's even if you had a few inches of movement in the roof, the house had to be torn down. And that was where we saw a lot of that damage, and it
Right.
really
Right.
cost quite a bit in there. But if those roofs had been managed to stay on, you'd have a lot of damage, but you wouldn't have to rebuild the house.
Right. Okay. And just in terms of so like you said, some of these places weren't built to spec.
Yeah.
And also besides that, some houses, older neighborhoods were built before these conditions were a problem to begin with. So, not to this extent anyway. So, what are some things that, say, a residence or even like an office building or like a high rise, what can they do to mitigate against this after the fact?
Well, after the fact, there isn't, it's just a matter of rebuilding. But
Oh, I mean more after the fact of, okay, climate change is here now. What do
oh,
we do?
yes,
As
yes,
opposed
yes.
to, yeah.
Well, one of the things that I was working with the Northern Tornadoes Project, the guys from there, and Greg Kopp's one of the engineers, one of the wind engineers, and one of the most important things we can do for residential housing is to put something as simple as hurricane straps on, and all you have to do is pull the soffits off and put on these straps, and that will keep your roof on much better. Because again, we build for snow loads. We're not thinking
Hmm.
about the load that comes in the opposite direction, and that's what happens with tornadoes, even high winds. It tends to want to lift that roof. But if your roof stays on, you put those hurricane straps on, and you're going to be that much. You're going to be that much better. If we can keep that roof on, you're going to be fine. Having said that, if you're into EF4 and EF5 tornadoes, which are the strongest and second strongest,
Hmm.
it's not going to matter what you have.
Right. Yeah.
At
Yeah.
that point, that these are the kind of winds that throw trains around. So, you're not going to be worried. That's just, we're not really building for that.
No, you
What
couldn't.
we are
Yeah.
building for is the EF0 to EF3 tornadoes, which is, a structure can survive that. And if you keep that roof on, it's going to be, repair as opposed to rebuild. And that, of course, is going to save lives as well as save the buildings themselves. So, retrofitting for that kind of thing, that's a big deal. One of the other points of failure is the garage. Not, big wide area where that garage door can just sort of
Hmm.
be hit or pushed in just because of the wind load on the garage door itself. So if we can strengthen that, make sure that it stays closed, you're not going to have that wind getting into the garage and pushing upwards on the roof or on the ceiling of the garage. So there's a few points of failure that if we strengthen for those, your house is more likely to survive.
And then another climate change thing that we've seen a whole lot of over the past couple of years, especially this year, is wildfires. So how does that
Yeah.
figure into all this?
Well, what's interesting about wildfires, as we see a drying out of the environment in certain areas of Canada, we are going to see those increased levels of fires. There's not much you can do
Hmm.
to survive something like that, for your place to survive something like that. And it's definitely not my expertise. But what is interesting for that sort of thing is that one of the things that we found is that the smoke from the wildfires is actually suppressing tornado and thunderstorm
Oh, okay.
development across Canada and even across the United States. So, like this year, we didn't see that many thunderstorms in Ontario, even though we expected it to be extremely active, and we just didn't have that many. And the ones that we did have was just a lot of rain, and the tornadoes that we saw were sort of buried in that rain, so not very photogenic and not very powerful.
Hmm.
And that was likely thanks to a lot of that smoke that came across. It disrupts the heating a little bit. Gives you a little bit of dimming, so you don't have that really extreme heat. At the same time, it provides just a little bit more dust and debris in the air, so that creates the conditions for more rain. So it's one of those things that has all kinds of unintended effect, or at least
Right. Yeah.
unknown effects. So the atmosphere being so complicated, it's a fascinating thing to watch and try to understand exactly what is going to happen with climate change as it begins to affect all of Canada.
And I guess another thing I'd ask is, as somebody who's kind of, well, not kind of, you are on the front lines, as literally. So, what do you see in terms of people's awareness of just these severe weather events and how at risk they are to begin with, and also in terms of, when you see the construction guys coming afterwards, how do you see more responsive and responsible, I guess, attitudes than you used to?
It's a good question. One of the things that I've found more than anything is the availability of information.
Hmm.
We go back 10 years, there was no such thing as smartphones. Or at least, there might have been six of them.
Right.
And now, we can get that information out to your phone instantly. We don't, the Weather Network doesn't actually put out the watches and warnings, but what we do is get that information out to everybody. So Environment Canada puts out a watch or a warning, or a special weather statement, or what have you, and then we can get that information out. So the Weather Network, has a big audience, so people are able to sort of, get that information quickly, and because they get that information quickly, there's just a greater awareness of what's happening. And in Canada, I think we've got a big advantage over a lot of places in the United States, is that most of us have basements, so we've kind of got built-in storm shelters. If there's if there is a tornado, you can just get downstairs very, very quickly. Whereas in the States, quite often it's just, house on top of slab construction, especially if we're talking places like Oklahoma, where the ground is extremely hard and it's extremely expensive to put in a basement, and the water table is very, very high, et cetera, et cetera. So, they have to put in proper shelters, and you don't necessarily have them as many as you need. But here in Canada, because we have basements, we can get downstairs quite quickly. And I've seen more than one house completely swept off its foundation with a basement, and the people in the basement were totally fine, and the entire house above the basement was gone. I mean, just
Wow.
just demolished, and the person in the basement was absolutely fine. So there's a bit of that. So you add in a little bit of that, and us in Canada, we get so much media from the States, and they're sort of the hotbed of tornado activity and severe thunderstorm activity in the world. We're number two, but they're number one. And so we do get that awareness, so people have a pretty good idea of what to do. Now, we haven't necessarily translated that over into construction and how we build our buildings, but I'm hoping, and we're trying to sort of push that and try to get people to sort of understand that we can say, it's easy to save your life, but we can actually save your building too if it's built properly. Number one is saving your life. Number two is keeping your house intact.
Okay, and I guess people would, if they haven't heard of you already, where can they find you and find out more and sort of tap your expertise? Because I think you do articles and that sort of stuff as well.
Yeah, I've done quite a few. I've actually begun to put hurricane straps on my house. So I did a thing with Greg Kopp about that. You can find me on the Weather Network. I'm always doing something incredibly stupid on there, safely but stupidly. And then, of course, if Twitter hasn't been completely destroyed, Storm Hunter TWN, and then I'm on same name on Blue Sky and Threads and Instagram, that sort of thing.
Okay, great. Thanks for joining us today, Mark.
No problem. My pleasure.
And next, I have an interview with Greg Kopp. He's a professor in Western University's Department of Civil and Environmental Engineering, as well as the Impact WX Chair in Severe Storms Engineering and lead researcher in the Northern Tornadoes Project. He spoke to me about the work he's done with the project, how building codes are catching up to our current climate crisis, and what's being worked on right now to protect us and our buildings from future extreme weather events. I'd like to start with your background. How'd you get in the Northern Tornadoes Project, and what is it?
Well, the Northern Tornadoes Project is a project that we began in 2017. We believed that a lot of the tornadoes in Canada were not being identified, and we thought the true number of tornado occurrence was much higher than was being identified. And we started the project to do that, and we started in 2017 looking for tornadoes north of Superior. Basically, was our target area. That summer, we found a large outbreak in Quebec. Actually, we looked further afield, and we found an outbreak of over 20 tornadoes that had gone unnoticed. And based on that, we decided we grew to do all of Ontario in 2018. In 2019, we started doing all of Canada. So that's where we started. The project started actually with a brainstorming session with Dave Sills, who was at Environment Canada at the time, and a funding partner. And we were looking for a project on tornadoes that we thought was important, but that the usual grants, I'm in the university sector, we thought the usual grants wouldn't cover it. And we worked with the funding partner on this project. We think it's important to identify the true occurrence of tornadoes in the country to have a really good sense of what's actually happening.
And your background is, well, you've got a PhD in mechanical engineering, so you know the sort of the technical nitty gritty of how buildings can resist this, because it's not just looking at tornadoes; it's figuring out how to. You can't really resist them, but suffer less, I guess would be the best way to put it. So how do people go about residential, or I think you're also involved with a thing called the Three Little Pigs Project, which I'm assuming is residential.
Yes.
But also besides that, how can institutional or other buildings like industrial buildings, how can they reinforce themselves or fortify themselves against tornadoes?
Yeah, well, it's a great question, and it's something that's coming up more and more in the public as communities try to deal with resilience with severe weather and the changing patterns of weather that we have. So to deal with to get a better handle on how to deal with tornadoes, you have to understand two things. We have to understand the forces acting on the buildings. So that's an aerodynamics problem. And then we have to understand how strong buildings are. And so that's the resistance or the strength of the building that needs to be understood. So it's you need both of those parts. So for the loading part, we use wind tunnel testing. At Western, we've had boundary layer wind tunnels for a long time, over 60 years. We started working on wind here in the 1960s, actually with design of the World Trade Center towers way back then. And tornadoes are a little different. They're swirling. We built something called the Windy Dome, which is the largest tornado simulator in the world. And so we can put buildings in there and measure the aerodynamic forces that the wind puts on them. And you mentioned the Three Little Pigs project. Something like that is important for understanding how strong buildings are. And so houses are actually pretty complex to understand. They use wood 2x4s and drywall and brick and siding, and all these things contribute to the strength. And a lot of it isn't engineering materials. The drywall, no engineer relies on drywall for the strength of a building, but it actually contributes to the strength. So to actually understand how a building performs in a tornado, you have to understand things like that. Engineered buildings are easier using steel and concrete. We have really good models for those, and so we can estimate their strength. The big issue often with windstorms, though, and tornadoes in particular, is the wind pressures tend to break the building envelope, the cladding, the windows, the doors, the roofing materials. All those are really vulnerable. And then tornadoes are really bad for windborne debris. So all this stuff breaks, it flies through the air and hits downwind structures. So windborne debris is a big issue. And so we're trying to understand all of those different aspects. We've done a lot of work on understanding how pressures break windows and how it pulls sheathing off of roofs and things like that. We've also studied windborne debris to understand how fast things fly. It's amazing, actually, like a piece of plywood can travel at the same speed as the wind. And that's why you see these incredible things like 2x4s going through concrete curbs right at the ground and stuff like that. It's absolutely terrifying, actually, what the debris does. In the Didsbury tornado this past July 1st, for example, a 10,000 kilogram combine was flown about 100 meters. And if you think about that, it's actually really remarkable. So the power is scary in so many ways.
That's substantial force. Like I said, you'd understand it better than I would, but yeah, that's I mean, it is physics, but that's some crazy physics. And so you're also the chair, I think, or have served as the chair of the ASCE 49 Standards Committee on Wind Tunnel Testing for Buildings and Other Structures. So I guess my question is, what goes into that, but also have you seen, since we're being confronted with not only windstorms and tornadoes, but stuff like, wildfires and all these other conditions, that it's clearly evident now that climate change is a problem. Have you seen any progress on this side of things in terms of rules and standards and testing? And has there been more interest by government, or are they still catching up, I guess is what I'm asking?
Yeah, that's a great question. So like, we haven't historically designed anything for tornadoes except for nuclear reactors. And the reason for that is, well, with nuclear reactors, obviously the risk is really high if something bad happens. They're actually designed for vehicle impacts at 200 miles an hour, right? So they're designing for the worst possible scenario. Our electrical grid's really vulnerable to tornadoes. We call it a big tornado net across the country. So that's starting to be designed. In the United States, ASC 7, which is the main loading standard that goes into the building codes, has tornadoes for the first time in 2022. And that really was an acknowledgement that losses from tornadoes and thunderstorms generally are about the same on average every year as hurricanes.
Mm-hmm.
And of course, hurricanes are designed for. In Canada, we still don't really design for tornadoes except for reactors and the beginnings of the electrical grid. But we do have a standard now for wood frame houses, CSA S520, which is the first consensus standard in the world. And it's for wood frame houses up to EF2 tornadoes, which is 95% of them. So we can actually make houses resilient for that. And it doesn't actually cost too much money. We have a project right now that we're working on trying to get tornado design loads for the National Building Code of Canada. And so we're working towards that. So this is something that will be out, but the code process is slow. So it's new codes come every 5 years. So we're probably looking like at 10 years from now, we might have tornadoes in the Canadian Building Code.
And that was my next. You mentioned wood, mass timber, especially out here in Vancouver, is it's being pushed for many good reasons as the next material to use. But how resilient is it to stuff like extreme weather of any sort?
Well, it should be good. Once engineers get involved with design, as it would for these large wood frame structures, the structural safety goes up quite a lot compared to what we have for houses, which are built to prescriptive standards.
Mm-hmm.
One of the things we've observed with tornadoes that even though engineers don't design buildings for tornadoes, they tend to do pretty well. Examples of that are like the hospital in Joplin, which went through a terrible tornado in 2011. The hospital is actually a write-off, but the structure survived completely. The hospital is a write-off because all the windows were broken and all the contents were wrecked, and they had to pull the thing down because they lost infection control and all those kind of things. So that becomes the issue is protecting the skin of the building. So I'd expect for mass timber construction, I think it's going to be fine. It's there's still details to be worked out with that, how they deal with high wind in terms of motion of the building, so people are comfortable in the building. But the structural safety, I think, will be excellent.
And I would imagine if anybody's on the cutting edge of this kind of stuff, it'd be you and your colleagues. So what is sort of on the way and what is being worked on right now that isn't quite in mass production yet, but is being looked at as new ways of building stuff?
Well, we're looking at ways, again, of trying to protect the envelope of buildings. So how can we better design for protecting the windows and doors that keep the weather out? We have I think great building codes in Canada for energy efficiency. And to me, what we need to add to that is resilience. And so I think that's the issue that we're really focusing on right now, is adding resilience to the building code to go with the high energy efficiency. It doesn't make sense to make something highly energy efficient that ends up in a landfill because it was damaged or destroyed in a storm. So we need to and there's real challenges with that. Keeping water out is really hard. And these storms, and with it seems like a warming atmosphere, the potential for greater rainfall is increased. And as soon as that gets driven by wind, it's really insidious. And to keep that water out is really a challenge.
And finally, if people want to know about the Northern Tornadoes Project or your research generally, where should they go to find out?
Well, you should go to our website, and it's uwo.ca/NTP. So it's a pretty simple website to find. If you Google us, you'll find us.
Great. Thanks for joining us today, Greg.
Yeah, my pleasure.
And that's it for this episode of the Construction Record Podcast. You can hear us on Amazon Music, Apple Music, and Spotify, as well as the Daily Commercial News and Journal of Commerce websites. Thanks for listening.